All right, so let's look at another example of the first derivative test. So this time we'll take our function to be x squared minus y squared. And let's see, so the first derivative test that we're going to use to find our critical points tells us that we need to see where the gradient is equal to 0, right? So the gradient is composed of the first partial derivatives. So we go ahead and compute those. So differentiating with respect to x, we get 2x. And differentiating with respect to y, we get minus 2y. And so then we want to say, okay, where's the gradient equal to 0? So I'll just write it out for no good reason. The gradient is 2x minus 2y. And so the first derivative test tells us that we should set this equal to 0. So that gives us two equations. From the first coordinates, we have 2x equals 0, or x equals 0. And from the second one, we have minus 2y equals 0, so y has to equal 0. And so we get exactly one critical point. And so that's our single candidate for a maximum and a minimum for this function. And so then we want to say, okay, so is this guy a max or a min? Well, we haven't seen the second derivative test yet, so we'll just do sort of an ad hoc messing around with it. And let's look at a couple of traces. So if we take f of 0y, so this is the trace when x is equal to 0, then it just looks like minus y squared. So that tells us that the function is going to be decreasing away from 0 as you move on the y-axis. Right, so if we are sketching this guy, then it's saying that if we start from our critical point here at the origin and we go like this way, then it's going to be decreasing, and if we go this way, then it's also going to be decreasing. Meanwhile, the same argument shows that if we substitute y equals 0, so that we're on the x-axis, then it's going to look like x squared, and so this one's going to be increasing as you move along the x-axis. So in other words, if we go this way, it's going to be going up, and if we go this way, it's going to be going up. So we have one of these things going on. There we go. So that's the thing that we're looking at. So we call this a saddle. So a saddle point is like the kind of thing that you come across between two peaks on a mountain. And so if you're moving in one direction, then the saddle point is going to be the lowest spot on your path as you climb from one mountain peak to the other. But if you're trying to get from one valley to the next valley and you're going, then you aim for the saddle point, and that'll be actually the highest point on your journey before you start going down into the next valley.